Well, I'm delighted to be here today with my friend Christer from Sticker. Nice to have you here. He had quite some issues with arriving here, so it was late at night, and but he finally made it, so we're all lucky. All right, so, well, we know each other basically for 1 year now, and what has started with basically the development of a single EPD at the beginning has turned into something that is way bigger than that, because, well, Sticker, they're producing kitchens, as you can see here. And I mean, kitchens are basically products that are, yeah, you can have them in all sorts of configurations, and that makes sense to think of an LCA solution that can reflect that and create specific LCAs for each configuration. And so this is basically what we're doing right now. So we're developing a fully automated, well, LCA and to-be EPD tool, and we want to have you to have some insights today about what we're doing. So I guess let's get started, and well, we'll first have a look at why we think that well, LCA is not only something which matters for Sticker, but also, well, is something that really, well, the demand increases significantly, and what are the drivers behind that. And of course, we'll have a short look at why LCAs matter in this regard, because, well, everything needs to be basically scalable, and we think that only really tools can achieve this. Then Christer will take over and introduce a little bit to Sticker and how they imagine, or how their tool actually works, and so how they integrate LCA into their systems. And yeah, finally, we'll also have a look into how our tool actually works. So we cannot go that much into detail, but at least the principle of how it operates and how we create LCA and also, well, EPD results. And hopefully we'll have some minutes after that for some Q&A. So yeah, I guess this year is probably familiar to everyone, and everyone knows about this. So we have a couple of regulatory developments that drive the demand for LCA in general. What's not in here is now like Scope 3, for example, which would be another thing. But we have the Green Claims Directive. By 2028, we will have the battery regulation. And particularly, I want to emphasize the construction products regulation, which is currently under revision. And maybe let's have a deeper look into that, because for those of you who may not know, but probably most of you do, yeah, there will be a carbon footprint required for each product that falls in the harmonized zone. Yeah, by next year, basically, or starting by next year. And by 2030, it will even be required to have the whole environmental indicator set, which we know from today's EPDs, within the Declaration of Performance and the Digital Product Passport. And well, the whole development affects roughly around 400,000 manufacturers, according to EU Commission. And well, I mean, this is quite a number, and the funny thing is, yesterday evening we were discussing exactly this number together during the dinner, and we were making up the same, basically, well, calculation example. So if we just assume that each of those 400,000 manufacturers produces, let's say, 10 products that are regulated, so this is not scientific and very vague, but it's just for getting a feeling for the dimension, then this would mean that suddenly 4 million products require compliance with the CPR. And not only that, I mean, they're also required to have a carbon footprint and later an LCA, basically. So if we compare this to the number of construction EPDs that was registered early this year, according to the Eco platform, that was something like 23,000, we can see that the demand basically skyrockets, just explodes. And well, at the end of the day, it leads to the all-important question, like, how are manufacturers supposed to meet this reporting demand? And basically, our consideration is that only with tool solutions this will be possible. So yeah, Christer, maybe you can go ahead, because I think Sticker has quite a cool idea about how to integrate LCA into their systems, and maybe you'll just show what you're doing currently. So here you go.
Thank you, sir. Yeah, Stuttgart is a very transformative place, I think. They started as a laser cutting company, and later on they just thought, why not producing kitchens? Our CEO always says, we don't care about kitchens at all. We just wanted to solve the problem of the throwaway mentality of kitchens. Like in Denmark, for example, I just have the number from Denmark. Our kitchen lives 11 years. We have warranty on our kitchen for 10 years, which is a bold statement, I think. Out of this demand, internal demand, that we have so many kitchen configurations, we actually developed a tool that can help us with creating EPDs automatically. And yeah, we started to realize that there's actually a software company in our hardware company now, with our hardware being the first client of our software. And we talk to a lot of our clients and they say, interesting. We think maybe we are interested in linking up to our platform to actually also document their impacts, because it's sub-suppliers like wood fabricants and metal or steel parts from Germany, and all these sub-suppliers, they are not ready for these EPDs and they don't usually document these things. So we are really trying to push both backwards and forwards. What we do is we believe we have a high durable product, plywood made. We trace every single component of our product. So we stamp these QR codes on every single component where you have some space for QR code. So except for screws, maybe everything is traceable, because as soon as these kitchens go out to our clients, they actually can trace, and they can go into this QR code and check out their digital twin. And this is basically how it works. You have this thing, and you connect to it, you go in, you have a 3D model, you can click on the different components. Of course, this is we are B2B, so we sell 1,000 kitchens and so on. And of course, it has a value for the end user, like us buying a kitchen. But of course, it has much more potential for a lot of other actors in our supply chain. We built modular. Tesla was, so to speak, our idol in this, because they really streamlined. And when they produce a new model, it takes a half a year. Then the entire manufacturing is VW, for example, takes 5 years to align the manufacturing. So we do modular, we do durable, and we do traceable. For example, like the modular approach, you can, after a while, you can actually tune your kitchen and you can personalize them. And the modular approach, like when you look at an IKEA kitchen, something breaks. IKEA will tell you, hey, we don't have these parts in storage, but you get a savings on a new kitchen. So you throw the entire kitchen away, get a new one, because IKEA has too many parts in their kitchens. After 5 years, they run out. They produce new kitchens, so the old parts are not there anymore. So the whole business case is not aligned to actually a circular approach. And that is what we're trying to do with our QR codes. And yeah, just real quick, like product owners, the traceability makes them be able to repair the product, to extend their product lifespan, save resources by repairing instead of replacing. And on the other side, the manufacturers, they convert unknown product owners into lifelong customers. Because for IKEA, for example, the contact to their customers ends as soon as they sold the kitchen. We are trying to actually stimulate this interaction between end user and producer. So in the end of the day, that you actually can replace and repair your products. Yeah, we are playing with a lot of big people in Denmark. And we came and produced this product. So our ground truth is a 3D model. So everything that goes into production, except for T-shirts maybe, they have 3D models. Everyone has 3D models. And that is the ground truth because they go to production. So from these 3D models, we can extract volumes, we can extract all sorts of information. And create this kind of ID or digital twin ID where we, in a long run, maybe even integrate a web shop. Like, I need this groove for my chair. Where can I find it? So it's like basically a big furniture Facebook where people can interact and yeah, fleet manage in the end of the day. So if you have thousands of kitchens, you have a guy trying to, he gets a call from Sophie, and she says, my front is broken. He's going there, he has to call someone, and there's so many processes involved until this small front actually is repaired. With this thing, you can actually scan the QR code and directly identify where's the part, and you can directly inform your supply chain to actually deliver. This is how it looks. You upload a 3D model, and basically with drag and drop, you apply some materials. Our volumes from the 3D model, we can actually calculate, automate the weights based on the density of these materials. So we're trying to align this user interface to an EPD template, so to speak. You go chronologically through the different aspects of a EPD. So you start with materials, you go on with the transportation, in the end comes the packaging and so on. And you can apply some relevant information. These are all information that we found in the ILCD standard. And in the end, and that is a big thing, like how do we verify that this data is actually correct? You upload maybe some data sheets and so on, so to validate this information. Yeah, yeah, I think that's it from my side.
All right. So yeah, for those of you who maybe a bit confused right now, so the actual principle behind this is that the whole lifecycle inventory is basically created from those 3D models, right? So you get your data from your suppliers and ask them, okay, could you please fill in what your parts are basically made of, so which materials? And this information is stored in your database, basically. And so this is the way the inventory is being built. And what you can see here also is that it's traceable where parts come from, because, well, each supplier has, of course, an address, and then it's traceable, and you use your Google API, I think, to trace where the parts come from, and you can see this visualized. And so there's a huge amount of data in this database that we can leverage to basically create LCAs. And so that leads me to the part where I shall describe a bit how the actual LCA calculation works with our tools. So yeah, we've seen now the great example how to create the inventory. And yeah, here is how the actual tool really works, and I'll try to explain this in a very simple way. So basically what happens is, and the thing is, or the whole tool is basically built around an API. So we heard about APIs earlier today, so application programming interface, and this API takes the inventory data and transfers it into a parameterized model that is in the background. Now, the parameterized model automatically, basically in real time, calculates the results and sends them back to Sticker for further evaluation. I'll come to this in a second. So what we receive is a JSON file which contains a lot of information, but I'll come back to this in a second. So the model itself is created with iPoint's Umberto software together with EcoInvent datasets, and the whole thing is uploaded to iPoint Product Sustainability. And we need to do this because only with that we are able to use really an API. This enables the whole mechanism in the first place. So when I said that the inventory is being transferred into the actual LCA calculation, what I really mean is basically parameters. So earlier we have, for each material and also energy and basically anything in the lifecycle inventory, we have assigned specific parameters. And these parameter values are what are being transferred via the API. So here's a little screenshot of how this looks in the web interface of PS Web. We're not actually using this because, well, we're using the API, but this list of parameters, so in total we have 71, I think, in this model, and this is filled automatically. And you can see some parameters are set to 0 here, and it's just because, well, some materials may not occur in a certain kitchen configuration. So this is basically how that works. And well, what we've seen now is essentially how, on the one side, the inventory is being created. So we have the 3D model, and from the 3D model, we get a parts list. We know from the suppliers what the parts are made of. So with this, we can generate a bill of materials. And this is basically translated into parameter values. And now these are sent to the calculation core, which we just seen. And, well, now let's look at the output side, because we're not yet done. So we still have to do something with those results. And as I said, we receive a JSON file, which contains a lot of information. And that's not only the lifecycle impact assessment, but there's more to it. So it also includes information about the inventory, and it also includes information about the model itself. So basically, which process is in what life cycle stage and some other meta information. And we can use that with a little bit of data science and basically are able to produce any result we would like to. This can be a carbon footprint for the product, an LCA, or even a whole EPD. And now it gets really interesting, because if we have a look at, well, this is just a results table according to EN15804. And, well, currently most of the indicators shouldn't be a problem in any LCA software. So especially the environmental indicators, well, not really subject to issues. Total primary energy, fresh water, waste, all that should come out of the impact assessment, well, correctly, hopefully. But as probably most of you know, there are a couple of quite annoying indicators that always, cause problems, because they are, well, it's mostly necessary to calculate those manually. And I'm talking about these ones, obviously. So the primary energy, which is used as a material or as energy carrier, and also secondary material content, for example. And last but not least, the output categories, such as, for example, materials going to recycling. Yeah, so calculation by hand doesn't really go well with automation. So we had to think of a solution how to automate the calculation of this. And now what comes into play are certain rules in the modeling together with this JSON file with all the information. And this together, we were able to fully automate the calculation of these indicators as well. And I think this is really a big step towards fully automating EPDs correctly reflecting these indicators. And, well, I mean, there's more to it. So we can also automatically create content for reports, such as, for example, an inventory list or, well, graphics for interpretation. And also what we can export is a list of basically all processes and how they were mapped. So which data sets have been used to model that, and also the quantities. So what we basically get is the complete documentation of the whole LCA, at least the quantified part. So what's missing is, of course, some considerations why a certain allocation approach has been chosen, but everything that's quantified can be taken out of this JSON file. So I guess I'll have to come to an end of the presentation, but what you have seen so far basically is that we achieved quite a huge advancement in optimizing the efficiency of the LCA calculation. However, we are currently still in the transition from what you could maybe call an advanced LCA tool to a fully integrated EPD tool. And the reason is that we are currently, well, it's not possible right now to produce the actual EPD document itself. So this still requires some copy and paste by hand. And we're working on that. So you guys are doing that because your IT department is really quite smart. So we're working on that to actually produce a real EPD document by filling in the template provided by EPD International. But hopefully, and I can refer to the presentation we already had today, we're eager to also use the API once it is in place, because this is obviously the most convenient way to create an EPD then. So, yeah. That's basically the end. Thank you very much. I hope there were some interesting points for you, and I'm happy to receive any questions. And those I cannot answer right now, I'm happy to have personal discussions later this day. So thanks a lot.
Excellent. Well, thank you so much. Please stay on the stage. Would you like to join me here on this side, please? There's also just a bit of a notification. If someone has forgotten the black handbag, it is found. You can grab it. You have it already. Excellent. So, a question here. Is it clear how to automate the BOM? It is clear how to automate the BOM. But what about energy scraps and auxiliaries? That has to be evaluated with actual data on an EPD. How do you maneuver around this one?
That's a really good point. So maybe you could...
Energy.
It's clear how to automate the BOM, but what about energy scraps and auxiliaries?
Yes.
I mean, we have two parts. We have the quantified part and the qualitative part. And our UI covers everything that the quantitative part cannot cover.
Sorry.
Oh.
Otherwise, they see you sort of flickering in the light here.
So we have these input fields. The validation is a big problem. I mean, how do we actually make sure that people, our sub-suppliers and so on, put these right numbers in? And that is something we have to work with all of us, and maybe some feedback from here also tonight, because that's a big problem. Like, how do we validate this data? But that is already a problem. In the Excel sheets that we use today, people also just put numbers, right? Yeah, I think that is manual.
Would you like to add?
Yeah, maybe I add to that. Right. So yeah, you're asking for energy consumption and also scrap during production and so on. So yeah, the input fields are there, but yeah, how do you verify? But maybe we should also refer to your own production waste in the manufacturing of the kitchen. And I guess this is primary data which we know about, and we know what the scrap factor basically when cutting the plywood panels. So this is automatically considered in the whole model. So this is not even a parameter right now, it's just a fixed value that we add some more material on the input side. And energy, well, you know about your energy consumption, so.
Thank you. More questions coming in. Default EcoInvent data, especially wood-related data sets, come in different forms. For instance, moisture content, dry or wet. How do you deal with a simple matching between a kitchen material and the data set?
Yeah, that's quite a good question. So, I mean, we're still before the verification, but yeah, if you look at the availability of data sets for plywood, you just choose the one that basically suits the best. I was asking Krista, well, okay, can you give me some specs about what plywood you use? And then you just use that data set. The cool thing about our tool is also that we're able to, well, integrate existing EPDs if we would like to. So once you have, purchase plywood from a manufacturer that actually has an EPD, we could also integrate that EPD into our tool as well. So that's a quite new feature that we can cover. So, yeah.
And the PDF scraper, by the way, as well. Yeah.
Now, there's a question that is related to the first one here. Does the model only use generic material data from EcoInvent, or can you also include supplier-specific, but we touched upon here, LCIA data such as EPDs?
Yeah, that's basically what I just said.
Yeah, but could you sort of develop it a bit?
Yeah. So you can definitely use supplier-specific data, and if you say, well, you just need a carbon footprint, then it's maybe much easier because more suppliers may have a carbon footprint about their products. But if there's an EPD or ILCD file, yeah, we can basically create a data set out of that and integrate this into our model.
Thank you for elaborating on that one. Let's see. Are there strategies to reduce the huge amount of different parts in your furniture to fulfill the company's circularity approach?
Come again?
Are there strategies to reduce the huge amount of different parts in your furniture to fulfill the company's circularity approach?
So we reduced our parts to 150 compared to 2,000 to 3,000 in other kitchens.
Wow.
So we are using 150 parts. And that's why I mentioned the Tesla approach. I'm not a big Tesla fan, but they are really good in supply chains and switching production and so on. And that is exactly what we are doing. So Stücker is also kind of a logistics company, maybe, and in the future, because they always transform. And I feel like the putting a LCA on a visual map, on a 2D map, is already it's an eye opener for many people. And I wonder why not more people actually put these LCAs on a map and to analyze and to. It's really boring to read those EPD PDFs. So we just try to make it more sexy for people to look at it. Yeah.
Well, it's great work. And of course, you mentioned IKEA, the biggest kitchen supplier globally.
In Sweden.
Of course, they must be watching you. What do you think the implications could be for them, seeing what you're doing?
I know that they're interested. So, but they have a different business model. I don't know if they're interested in getting circular.
But they're claiming that
they claim a lot, yeah. So, but we in Sweden, I try to stay humble.
Lay it down a bit. A bit on the back burner. I get it. So. Another question here. How large would you estimate the gap is between the information you can generate from the JSON to an EPD that can be verified and published? I guess that's for you, Alexander.
Yes. So from a quantitative standpoint, it's already complete, I would say. So that's not the big issue. It's more about the qualitative part. So we still need to create this LCA or EPD report, not the EPD itself, but the whole project report, in which we argue how we calculated this and that. So this is still what needs to be done, of course. But other than that, quantitatively, I think...
Of course, we are looking into AI. I mean, product description, a kitchen. You make food and socialize, right? That's kind of the product description, and I'm sure that AI can handle that. And there's also like some lifestyle.
No walking on water here, no.
Life cycle stage description. All these kind of descriptive aspects of a EPD is covered by the UI, and the calculation. Yeah, they are conform, I think.
Excellent.
Yeah. We'll have to wait for the actual verification process, but
we're at the source here.
Yeah. I think it looks pretty good, so we did some tests internally, and the results came out pretty good.
Wonderful. Another question. Have you mapped also the region on the automatic mapping of an eco-event data set? For instance, wood coming from a country with respect to wood coming from another country?
Yeah, regionalization is kind of a thing. Yeah, we are able to integrate that in those parameters and could also regionalize. The thing is that most data sets basically, refer to a broader region, so it's more like an average. But once we have a data set that is super specific about the region, of course we could use that, and then we would create its own parameter, so it can definitely... You can definitely choose this parameter to be applied and not like the generic origin of wood, for example.
Excellent. So a final question from me here. In 5 years, if we meet here or somewhere else in the world and talk about this topic, where are we at then?
I hope we automated it in 5 years.
Alexander?
Yeah, and maybe, I think what we found is quite a promising approach to calculate LCAs and automate the whole thing, not only for kitchens. So the idea is maybe to broaden this a bit also for other businesses and product categories. So depending on we first should start with rather simple products and not just go directly into electronics or so. But I could imagine that in 5 years' time, a lot more products will have such a model in the background where we can, quite easily automate the whole LCA or
the cool thing is we're using the furniture PCR, and I mean, you saw we are already playing with chairs and tables and other clients coming, and can you not calculate this? It's so quick and easy. So there's a lot of demand, but I think we should focus on furniture for now and then expand when we have a robust model, or maybe creating different models for different furniture.
Excellent. Well, very impressive.